f of x is equal to limit theta tends to 0 cos pi x minus x power 2 by theta into sin of x minus 1 by 1 plus x power 2 by theta into x minus 1. Okay, now we have to check f of x is continuous or discontinuous at x equal to minus 1 and 1, right? First of all, observe here, in the function x power 2 by theta is there. Let us take first of all that 2 by theta is equal to some n is equal to some 2 by theta. This value 2 by theta assumed as n. Now if you take, suppose theta tends to 0, observe theta tends to 0 is the only there, no? Now when theta tends to 0, okay, as theta tends to 0, n tends to what? Now when you take 0, 2 by 0 means what? Finite by 0 means it will be infinity. So n tends to what? Infinity, we will get it. Okay, so the power value goes to infinity. Now here that x power n, when you take 2 by theta as n, no, so x power n, it behaves differently depending on the value of base x. Okay, cases you can take it now. Case 1 first. Suppose if you take that x value in between minus 1 to 1, that means mod x is less than 1 only, right? Base is the decimal or negative decimal, like that if you take means including 0, right? If you take means, now as n tends to infinity, x power n tends to what? Now you see the base is what? Decimal power infinity continuously multiplying means we will get 0 only, no? Now what about the function value exactly? F of x is what happened now, you see. What happened now? Substitute here, it means we will get cos pi x as it is, okay, minus this x power 2 by theta is 0, no, we got it. So it will be 0 into sin of x minus 1 by denominator 1 plus 0 into x minus 1, we will get it. That means what? This term is 0, this term is 0, only we will get cos pi x. It is f of x in this case. Okay, similarly case 2. Suppose if you take mod x is greater than 1, in this case what happened? See, as n tends to infinity, now x power n tends to what? Actually it's showing x power n tends to what? Base is what now here? More than 1 power infinity means definitely it goes to infinity only. Okay, now to do this f of x value, to find the f of x value, what we can do in these cases whenever infinity coming means we have to divide both numerator and denominator with x power 2 by theta. So see now, limit theta tends to 0, dividing both numerator and denominator with x power 2 by theta, then we will get cos pi x by x power n only, no, 2 by theta assumed as n, okay, by x power n minus sin of x minus 1 by, here what happened now again, 1 by x power n plus x minus 1, like this only. Now we will get, now you can see x power n tends to infinity, then 1 by x power n tends to what? 0 only. So 0 into any value, any finite value will get what? 0 only, no? So it's completely 0, only minus sign of x minus 1 is there, and it is also 0, only x minus 1 is there. So minus sign of x minus 1 by x minus 1 value is only left over. Okay, it is case 2. Now we will find f of x function exactly at x equal to 1 first. Okay, so case 3, exactly at x equal to 1, f of 1 value is what? So exactly at x equal to 1, right? So f of x is equal to, here theta tends to 0 cos pi x, we are substituting in the place of x as 1 only, no? So what about this value? See, limit theta tends to 0, we'll substitute later this, in the place of x 1 substitute means cos pi, and x plus 1 minus 1 power exactly 1, right? 1 power any value we will get 1 only, then sin 0 only, we will get 1 minus 1 sin 0 by, here 1 plus 1 power anything 1 only, and again 1 minus 1 0 only, right? So completely vanished, only sin pi is the, sorry, only cos pi is the left over here. So cos pi value is how much now? Cos pi value is exactly minus 1. It is the function value exactly at x equal to 1, right? Okay, now at x equal to 1, left hand limit, right hand limit, we have to check it, then only we can decide whether it is continuous or discontinuous. Then check it at x equal to 1, left hand limit and right hand limit. So what happened now here? Limit extends LHL first at x equal to 1. limit extends to 1 plus only, no? So 1 plus means more than 1. So which function we should take now whenever it is 1 plus, left hand limit, no, we took actually 1 minus, right? So 1 minus is compared to 1 small, no? So compared to 1 small means this is the function we should take cos pi x, and cos pi x we will take now in the place of x 1 only, no? While you are substituting, we will substitute. So cos pi value is what now? Clearly -1. Similarly, what about RHL? RHL is equal to limit extends to 1 plus. 1 plus means more than 1. This is the case. So in that case function is what? Minus sine of x minus 1 by x minus 1. And it is extends to 1 plus means x minus 1 tends to 0 only. And we have the formula limit extends to 0, sine x by x is 1. So this is also 1, before minus is there, so -1. So now observe, left hand limit, right hand limit, function value all are equal. So clearly the function f is continuous at x equal to 1. Therefore f is continuous at x equal, but they gave what it is discontinuous at x equal to 1 they gave, right? So clearly statement 1 is false, because f is clearly continuous at x equal to 1, right? Next, now statement 2 we have to check it, right? Statement 2, observe, LHL limit extends to -1 minus compared to -1 small, right? Compared to -1 small means what? It is not in between -1 to 1, right? So this is the condition again we should take. So minus sine of x minus 1 by x minus 1, minus sine of x minus 1 by x minus 1. So now we can substitute in the place of x as -1. -1 minus 1 -2 only, no? Minus if you take it outside means positive, so sine 2 by -1 minus 1 -2 only again, so 2 minus, right? So this is left hand limit at x equal to -1. Now right hand limit at x equal to -1 we will check. Limit extends to -1 plus means -1 plus means what? It is greater than -1, and it is in between -1 to 1 also. So this is the function we will take, cos pi x we should take, right? So cos pi x. Now we can substitute in the place of x as -1. Then we will get what? Cos of minus pi. Cos of minus pi or cos pi, both are same only, and the value is what now? -1. So observe now, left hand limit is not equal to right hand limit. So what happened now? Whenever LHL is not equal to RHL, we can say the function is discontinuous at x equal to whatever the value at -1, right? So f is discontinuous at x equal to -1. But what they gave here, f is continuous at x equal to -1, so clearly it is also false statement. Okay, so finally both are wrong. Then both are wrong means both are neither 1 nor 2 is true they gave, right? So option 1 is the correct one.